In this video, I'd like to cover nitration. And this is a very fundamental organic reaction. It's something that you're going to be introduced to at an undergraduate level. And this is very old chemistry indeed. It's been known for a very long time. And it's just a simple way of adding a nitro group to an aromatic hydrocarbon like benzene, which I've shown in this example. And this is useful because NO2 can be functionalized to a wide variety of functional groups. And so you can functionalize benzene very smoothly. These are kind of harsh conditions, but they work pretty well. And I've colored the NO3 in blue because actually the nitro group that ends up on the benzene comes from the nitric acid. And I'll show you exactly how that happens. So as I mentioned in my primer on electrophilic aromatic substitution, one of the goals here is to generate in situ an electrophile which is very electron deficient and can therefore be readily attacked by benzene, which, as I mentioned, doesn't want to disrupt its aromaticity. So the electrophile has to be very electropositive. And so the way this happens is thusly. We start with nitric acid, and we mix in sulfuric acid. The nitric acid deprotonates sulfuric acid, or we can say that sulfuric acid protonates nitric acid, and we generate this intermediate here. And of course, this OH2 moiety is a very good leaving group. And of course, that's exactly what happens. The lone pair on one of the lone pairs on oxygen comes down, displaces the water, and we get this NO2 positive species, which is called a nitronium ion. And this is extremely electrophilic. This is very electrophilic, and benzene is actually going to very rapidly attack it. And so that's exactly what happens. So here we have benzene and our nitronium cation. We show the electrophilic attack. And this basically is just the mechanism from here on that I outlined in my primer. And what we get, of course, is the sigma complex. And finally, you get rearomatization via deprotonation. And here we have our product. So that's nitration.